Have you ever wondered how close we can actually get to the sun? The answer might surprise you because we've already done it. But how is it possible? How can a spacecraft survive the intense heat of the sun's atmosphere, where temperatures reach millions of degrees? Let's dive into the incredible journey of NASA's Parker Solar Probe, the first ever mission to touch the sun, and uncover the fascinating science behind it. It all began with an idea that seemed like science fiction. In 1958, the same year NASA was founded, scientists proposed a daring mission to the sun. But there was one glaring problem. They didn't have the technology to make it happen. How could any spacecraft survive the scorching heat of the sun? For decades, that question held back progress. After all, the sun's outer atmosphere, the corona, can reach temperatures as high as 1 million degrees Celsius or more. Even materials that we consider incredibly heat-resistant would melt in seconds at those temperatures. Fast forward to 2018, when NASA launched the Parker Solar Probe from Cape Canaveral, Florida, marking a historic moment. The rocket carrying the probe Delta IV Heavy was among the most powerful in the world. And the spacecraft it carried was no ordinary satellite. This was a highly specialized, high-tech instrument designed to withstand the seemingly impossible, getting closer to the sun than anything before. But before we get to how Parker survives this deadly heat, let's first explore what makes the sun's atmosphere so mysterious and dangerous. You see, the surface of the sun, called the photosphere, is incredibly hot, around 5,500 degrees Celsius. But strangely, as you move away from the surface into the outer atmosphere, the temperature skyrockets. The corona, that outer layer, is hundreds of times hotter, reaching millions of degrees. This is one of the greatest unsolved mysteries of solar science. Why does the sun's atmosphere get hotter the further you go from its surface? It's like standing next to a fire, but somehow feeling colder the closer you get and burning up when you step further away. Scientists have puzzled over this for more than a century, and solving this mystery could help us understand not just the sun, but other stars too. The Parker Solar Probe is NASA's answer to this cosmic riddle. The spacecraft is designed to fly through the corona, that superheated outer layer of the sun's atmosphere. But here's the twist. While the corona's temperature is in the millions of degrees, the spacecraft isn't actually experiencing that kind of heat. How? It all comes down to something called the thermal environment. While the corona is incredibly hot, it's also incredibly thin. There are very few particles there. And heat transfer requires particles to collide with an object. So, although the corona's temperature is immense, the Parker Solar Probe isn't getting hit by as many particles as you might expect. It's like putting your hand in an oven. The air inside may be 300 degrees, but because the air is sparse, your hand doesn't feel the full force of that heat unless you touch something. Still, the probe isn't entirely safe. At its closest approach, Parker Solar Probe flies just 4 million miles from the sun. And the sunlight there is more than 500 times stronger than what we experience on Earth. To protect itself, the spacecraft relies on an innovative heat shield called the Thermal Protection System, TPS. This shield is made of a carbon composite that can withstand extreme temperatures. On the side facing the sun, the shield can reach 1,370 degrees Celsius, around 2,500 degrees Fahrenheit. But behind the shield, where the spacecraft's instruments are housed, the temperature stays at a relatively cool 30 degrees Celsius, about the temperature of a warm summer day on Earth. But that's not all. The heat shield is covered in a special white coating to reflect as much sunlight as possible, keeping the spacecraft cool. This incredible piece of engineering is one of the key reasons the Parker Solar Probe can get so close to the Sun without being vaporized. Yet even with this protection, the journey wasn't straightforward. The Parker Solar Probe didn't head straight for the Sun after launch. Instead, it took a series of long, looping orbits, using the gravitational pull of Venus to gradually adjust its trajectory and speed. This gravity assist from Venus allows the probe to get closer to the Sun with each pass, spiraling inward over the course of 7 years. In fact, Parker will make 24 flybys of Venus throughout its mission, each time getting pulled closer and closer to the Sun's corona. Then, in April 2021, NASA made a stunning announcement. The Parker Solar Probe had officially touched the Sun. It had crossed a boundary known as the Alphane Critical Surface, where solar material becomes untethered from the Sun and begins flowing outward as solar wind. This marked the first time in history that a spacecraft had ventured into the Sun's atmosphere, a place where temperatures soar and solar wind speeds reach millions of miles per hour. But what did Parker find inside the corona? One of the most intriguing discoveries was something scientists call switchbacks, kinks in the magnetic field lines of the solar wind. These sudden reversals in direction had been observed before, but no one knew where they came from. As Parker flew closer, it found that these switchbacks originate near the Sun's surface, in regions where magnetic energy funnels outward. These magnetic funnels may be a key to understanding how solar wind is accelerated to such incredible speeds. As Parker continues its mission, scientists hope to uncover even more secrets about the corona, including why it's so much hotter than the surface of the Sun. These answers will help us understand not only our own star, but also the behavior of other stars across the galaxy. It may even provide clues about how to protect our planet from solar storms that can disrupt satellites, communication networks, and power grids. In the end, the Parker Solar Probe is much more than just a spacecraft. It's a symbol of human curiosity and ingenuity. By venturing into the unknown, it's helping us answer questions we've had for generations. And as it continues its journey, we'll keep learning more about the Sun, the star that makes life on Earth possible. With that said, thanks for watching, and until next time.